either you missed elimination or substitution, and then you didn't really understand it when I went over it. You know, I went over it like 3 days, and then you missed it. So I think you missed it, and you never came to see me to make sure you got it, or to get my help with it. So if you miss, even if it's a school-related activity, we're still doing math in math class without you. So either you're going to be on top of things, and your grade will reflect that, or you're going to forget to catch up, and your grade's going to be what it is. And then, of course, all of us have bad tests. So some of us, it was just a bad test. It happens. We're going to rectify the situation. It's going to be okay. But, okay. I've been hating lately our bell ringers. They have been taking up way too much of our class time. I love a good question. Again, I'm still mad at you about point slip, so it's still coming sometime this week. You know that. But at least these questions to me are what we discussed when we were doing literal equations. So I'm much happier with this week's bell ringers. Acceleration equals the increase in speed divided by the time in seconds. Someone tell me your equation.
A equals S divided by T.
Perfect. Okay, and then I need someone's equation for B. Please, ma'am. Perfect. And Kayla, do you have C or no? Go ahead and tell me. So LWH. Perfect. I'm much happier with that. Now, I wish they had said do this and then rearrange the equation for L or something, but I'm much happier with this. Okay, today we just have a little foldable thing we're going to make. We do not have a worksheet to go with it, so when we finally finish it, we've already discussed what you should be going back to do. We need to fold this thing first. Take your paper. It says graphing inequalities. Let me zoom out as far as I can. Fold your paper in half like a book with graphing inequalities ending up on the back side. So let me show you again. Here's my full paper. I fold it in half. Graphing inequalities is now on the back side. For sure. Fold it in half. Graphing inequalities is now on the back side. Okay, is there anyone else who needs help with it? Aubrey, you know how to fold it? Tiffany, will you help him? He doesn't. Yes, dear. Yeah. For the first fold, yes. Okay, so is everyone here? We'll give them just one more second to get to here. Okay, and then Allison's already on it. So we folded it in half. Graphing inequality is on the back. We're going to fold that in half. So now we really have fourths, and graphing inequality has now made it back to the front. Okay, we're going to cut it, and if you want to glue it to a piece of paper, you can. It makes it a little easier to deal with. So I'll give you a piece of stinky graph paper if you'd like to glue it to that. Emma, Natalia, you know where the scissors are. Will you get the scissors? Allison, will you get the grown-up scissors out of my desk? Emma, will you give these 3 sheets out to your group, and I'll find more. How many more did you need? That's it?
Doesn't matter.
Yep, sure.
Okay. So now that you have scissors, I'm going to still key on this for a second. We give everyone this. Okay, now that you have scissors, what we're actually going to do is cut the split. We're not going to cut the back side. I'm not going to cut this half. I'm only going to cut the side with the lines. So I'm going to open it and just cut the side with the lines. Cut, cut, cut. That's all. Jen. Yes. There. There you go. Yeah, you don't have to glue it on there. I just think it's easier if you glue it on there. But you don't absolutely have to. I'm going to. We're going to do 2 examples on the graph paper, so I was going to glue it so I would know they went together. But it really doesn't matter to me. Okay, we're still on what we were talking about last week. We're still talking about inequalities. And you already know how to graph multiple and linear inequalities if you've been working on your stained glass project. For the most part, at least. Okay, is there anyone who needs help with their splits or anything?
You have some glue or something?
I do in that bucket. Over dramatic. Okay, if you got all that done, we're going to go ahead and get started then. We're not going to put anything in that first flap. It says a linear equality is similar to a linear equation. We like to graph an equation. We have to solve for y in order to graph. So the second flap says solve for y, and then plot points using slope and y-intercept. So it's really a review of what we were working on last week. So I need to subtract x, and I'll have negative 2y less than negative x plus 6. So we didn't do anything in that first flap. It was just a reminder that it's just like graphing a line. In the second flap, we're having to solve for y. I'm going to divide both sides by negative 2. And this would be the important part. What happens? We have to flip the sign. So it's y is greater than, and then what should my equation be?
Negative x over 2 plus 3.
And I'm going to mark that as negative 1/2 x plus 3, just because for me that's easier, so my slope is up 1 over 2, or down 1, you know, whatever. Yes, dear?
Wouldn't it be a positive because you divided a negative by a negative 2?
Oh, it should be a negative 2. Miss Compton did not write that. Thank you, dear. So it should be positive there and a negative there. I'm going to have to get out my whiteout. Should be a positive 1/2 and a negative 3 because we were dividing by a negative 2. I don't know why I didn't show that, and I don't know why my whatever's not working with whiteout. That's not working. There it is. Good. So Josh is right. I forgot when we were dividing, I was dividing by negative 2. So negative over negative was a positive 1/2. And then a positive 6 divided by a negative 2 was a negative 3. So it should be y greater than 1/2 x minus 3. Thank you, Josh. Okay. our next step is to actually graph. That's why it says plot points using slope and y-intercept. I have one person in this room who's putting the y-intercept on the x-axis. Make sure when it says -3, you go down to -3 on the y-axis and put your point. And then the slope is 1/2, so up 1 over 2. Up 1 over 2. Down 1, left 2. Okay, I'm ready to connect my dots. What kind of line do I use? I have got to use a dotted because it's not, or dashed, either way, but not a solid line because it is not greater than or equal to. It's only greater than. And since it's a greater than, I need to shade above it. So everywhere above it, I'm going to shade. And know your shading does not have to be beautiful. I know you've turned in this worksheet, so it's too little too late to fix it. And I swear I said this last week, but hear me say it again this week. The blue that I colored in is my solution set. The dotted line is not part of the solution. So if they ask you about the point 0, -3, that's not a part of the solution because it's a dotted line. If we had done a solid line, that would be part of the solution set. So anything on that dotted line is still not part of the solution set. I know there are a couple problems at the bottom of the worksheet you just turned in that asked about that. The false, true, false, whatever. I bet you're going to miss that up. If you missed it up, it's going to be for that. Okay, and then if we flip open our flap, solid or dotted. Solid if it's greater than or equal to or less than or equal to. Dotted if greater than or less than. So since we had a greater than, we did dotted. And since we had a greater than, we shaded above. And then I think it's best to always do a test point. And I told you my favorite test point, if it's in the solution set, I try it. I always like to use 0, 0. If he's in the colored in part, that's the one I plug in. I especially would need test points on my stained glass project, because when they started being lines like this, you know, when it's like this, I get above, below. But when it's like this, is this above or is this above? You have to plug in a test point or else you will go crazy. Okay, so if I plug in 0, 0, 0 minus 2 times 0, is that less than 6? 0 is less than 6. This is good to go. Are there any questions about this? Again, this is really a review of what we were doing last week. We're about to step it up one tiny, tiny notch, but this is what we were doing last week. And I'm sure you understood that, especially if you went ahead and turned in your stained glass project. That means you've done this a lot and you're good at it. Everyone ready to go on? Okay, then I'm going to go to my graph paper now, which is on the back of mine. Or if you have yours on separate paper, that's fine. We're going to do 2 examples. I'm going to call it 1A and 1B. Example 1. Graph each system of inequalities. And now you should be scared. Because all of a sudden your worst nightmare has come true. Because that word system means what you think it means. What does it mean we're going to be doing? How many? There's going to be 2. We're going to have to graph 2 at the same time. So for A, and thankfully they were gone ahead and solved these for us, we need to graph y is greater than 2x minus 4. And we need to graph y is less than or equal to -1/3 x plus 5. If you don't have colors, now is probably the time you want to use colors. you're more than welcome to borrow some out of my little tower things. Now is the time for colors. I'm going to put my coordinate plane below it. And we shouldn't have used my sneaky graph paper because Lord knows it's tiny. It's so tiny that I'm going to do every 2 slots. So I'm going to say that's -1, -2, -3, -4, -5, -6. I would have 3. 1 for the coordinate plane, 1 for one line, 1 for the other line. But you can have more if you want. I shouldn't have given you my stinky paper. I should have given you decent paper. Oh well. So I'm going to do every 2 dashes as a mark. So 1, 2, 3, 4. Otherwise, it starts being super tiny. If you don't want yours super tiny, you probably need to copy me on that. Okay. So I have my coordinate plane. I've got to graph both lines. There's 2x minus 4. So I need to go down to -4, put my intercept, go up to over 1, up to over 1, up to over 1. You can keep on going if you want. 2, 1. Do I do my line? Dash should have been there. Miss Compton, you can't do graphs today. Trying to graph, but poorly. When I connect my dots, do I use a, that's awful. I need regular paper. I just cannot. If you need regular paper, then I will give you some. I cannot do the typing. Tiny is too tiny.
Yeah, that was too much work. Yeah.
So Tyler, your people have regular paper and I need to send y'all stack.
I think they're sticking with that.
Okay, you can do whatever you need to do, but mine's just ugly. I can't. So it's supposed to be y greater than 2x minus 4, y less than or equal to -1/3, x plus 5. I was graphing. And I was having a moment, but now I feel much better. So for the 2x minus 4, I'm going to do it in pink. Go down to -4. Go up 2 over 1. Up 2 over 1. Up 2 over 1. Much easier. Oh my gosh, I hate the tiny graph paper. It was free. Otherwise, I would chunk it. Okay, do I do a solid line or a dash line?
Dash.
Okay, so I do a dash line, and then where am I supposed to shade? Oh, and I'm not doing dash. I'm not even listening to, she told me what to do, and I didn't even listen to her. When you're hot, you're hot. When you're not, you're not. Okay, so I'm going to shade above. I agree with her on that. So I'm going to shade up here. I did. If you want to mix and match colors here, you can. I'm going to try to be consistent for once in my life. Is everyone good to here? Josh, you got to turn it off. They got it on, and I'm about to burn up. You're so close to it. Thank you, Josh. Okay, if you've got this, let's go ahead and graph the other line. We're going to go up to +5. 1, 2, 3, 4, 5. This is where if you don't have a second color, life is about to get tricky. Okay, so I put my point at positive 5, and then I counted down 1 over 3, down 1 over 3, down 1 over 3, and I graphed this second line. It's in brown. So I did one line in pink, and I did one line in brown. When I connect my brown line, do I use a solid or a dashed line? Solid, because it's less than or equal to. So I have a solid line. And then with less than or equal to, do you shade above or below your line? Below, she said. No. This is a brand new thing. It's a brand new thing. This is why I would suggest using 2 colors, because otherwise, if you're using pencil, you're going to notice a bunch of pencil area. Maybe you notice this one's a darker pencil-y area than the others, but with colors, it really stands out. Notice that there is a region that I've colored. My 2 colors were brown and pink. Notice there's a region that I've colored both brown and pink. With a system of equations, we were looking for where the lines crossed. That was our solution. With inequalities, the system of inequalities, where the shading crosses is our solution. So this, that hot mess of pink and brown, that is my solution. So this is my solution. Now, I even write the word solutions on it. So the region where they overlap in color, that's your solution set. So if you wanted to do a test point, Lord knows I love me some 0, 0. You could plug it into both and check. So 0 is greater than 2 times 0 minus 4. 0 is greater than negative 4. It works out with the first one. With the second one, 0 is less than or equal to negative 1/3 times 0 plus 5. 0 is less than or equal to 5. It works out with the second one. I know I've shaded their overlapping is correct because I took a point from that region, plugged it in both, and it still worked. Do you absolutely have to do all this? No, but I want 100 in math class, so I do it and have a test point just in case. Are there any questions about that? Okay, we're going to do one more, and I swear that's all we're going to talk about because that's all you really need to know. So here is 1b. Our 2 equations are going to be x is greater than negative 3, because obviously we need to practice that again based on the stained glass questions I have. And then y is less than negative 1/2 x plus 4. Okay, I'm going to graph the bottom one already because I know everyone in the room can do that. Up to 1, 2, 3, 4. Down 1 over 2. Down 1 over 2. I'm going to do a dashed line because the second one is just less than. And since it is a less than, where do I shade? Below. So I'm going to shade everywhere down in here. I'm going to graph this one in pink. It says x bigger than negative 3. This is where we're all getting a little mind boggled. Where is x in negative 3? Where does that happen? Does that happen here? Or does that happen here? It happens on the x. So x, -3, we have to go on the x, which would be there. So I then put my line there. Okay, and then it says bigger than, and back to, oh my gosh, what is bigger than? So if I am confused, because this line was horizontal, which side is the bigger than side? I would probably guess the right side. But since I'm not sure, you know I love me a good test point. So 0, 0 is in where I think I should be coloring. So I plug in 0. Is 0 bigger than -3? Oh yeah, it is. So I'm right. I get to color in over here. The solution is not just this brown stuff. It is not just this pink stuff. The solution is where I have brown and pink down here. This is my solution set. These are my solutions. So I guess that's the main thing we need to learn today. Is unlike systems, we're not looking for just one point. We're looking for where the shading overlaps. That's our solution set. And if I really wanted 100, again, I would plug in 0, 0 and make sure everything checked out. Are there any questions about that?
Do you have the right solution?
You do not have to write solutions. I'm just proving a point. All you have to do is graph both lines, and where they overlap, that's understood to be the solution set.
So,
I can tell you.
for the first one, okay, so I got how you graph.
You got how it's shaded?
I didn't know you said.
Okay, so I was questioning myself, since it's a straight up and down line, do I color to the left, do I color to the right? Wasn't really sure myself. I love to plug in 0 and see. So I plugged in 0. 0 is bigger than -3, so I knew for sure to shade to the right. I'm telling you, I always use 0 when I question my affinity with inequalities. In that region where they overlap, that is our solution set. So potentially they could start giving you ordered pairs, and they'll give you an ordered pair here, an ordered pair there, and then an ordered pair in the overlap, and ask you the solution. Kaylee.
So we have an up and down straight line, so always the right will be
Straight in. Well, it should be if we've, unless we've we could have made a mistake in our work where we didn't flip the sign we were supposed to. So I don't want to say always, because what if our work's incorrect? But yes. Okay. Anyone else have a question? Okay, then you know what you should be